Hi everyone, let's get started on lesson 2 of unit 6 on the quadratic formula. So lesson 2 is all about the discriminant. And before we get there, let's just first state the quadratic formula. So first of all, we know that the quadratic formula solves for the x-intercepts of y equals ax squared plus bx plus c, i.e. it solves this equation. So if we imagine a parabola, okay, it will be solving for the x-intercepts of that parabola. So we write it in the form x1, x2, negative b plus or minus, and unfortunately, guys, you just have to memorize this. Okay, and we said that, x1 or one of the x values is when we take the positive square root, and the other x value, x2, is when we take the negative square root. Okay, so we've stated the quadratic formula. As a warm-up, I'm just going to use the quadratic 4 times to answer the following 4 problems. Okay guys, so I have solved the 4 examples that were given. Hopefully you followed along. And next I want to associate what's going on in the quadratic formula with what is going on in the graph. So what we'll notice, or what I've done on the next page, is I've taken these same exact 4 quadratics and I have graphed them. So right now what I just want to do is copy and paste the x-intercepts I already found. Okay, so another thing I want to mention, so we can actually pretty clearly see that the x-intercepts agree with the graphs. Okay, we have 1 here, we have 2, and we can see that they're actually quite ugly. Okay, and here we have none. Okay, and what I also want to point out is that we said that a couple of these were actually really easily factored. So when I say not factorable, I mean we cannot find integers or nice numbers to factor this. Maybe I should correct this. Too difficult to factor. Technically, we could write this as x minus 1 minus root 7, x minus 1 plus root 7, but that's pretty difficult to do. Okay, so what I've done here is I've just sort of summarized what we've done with the quadratic formula and I think how it relates to the graph. So now I want to double back to these calculations and point out what actually the discriminant is. So the definition of the discriminant is just the part under the square root. So it doesn't include the square root. Okay, what we can see is if we look at just this piece, okay, And if we call this, if we define this discriminant as b squared minus 4ac, or just the thing that's under the square root, we'll notice something about the value of the discriminant. By the way, this triangle is what we use to denote the discriminant. Okay, so if we notice here, our discriminant equals 81. In this example here, our discriminant is 28. So I'm just looking at b squared minus 4ac. Okay, we'll notice in this case that the discriminant is 0. That's interesting. What does that mean? And here we'll notice that our discriminant is negative 31. So hopefully by now you can see that the value of the discriminant actually has a relationship with how many x-intercepts there are in our graph. So let's just recap this. We can see that our discriminant in these two cases is greater than 0. We can see that our discriminant here is equal to 0, and we can see that our discriminant here is less than 0 because it's a negative number. So let's just reiterate that here. Our discriminant is 81, 2 x-intercepts. Our discriminant is 0, 1 x-intercept. Our discriminant here is 28, 2 x-intercepts. And here our discriminant is 0, and we have no x-intercepts. Okay, so just to summarize here, okay, we've defined our discriminant as b squared minus 4ac. And what you'll notice also is that if the discriminant is a perfect square, it's nice and easy to factor. Okay, so let's summarize this. We define the discriminant of a quadratic as b squared minus 4ac, and the discriminant helps us determine how many x-intercepts our parabola has. Okay, if it's greater than 0, our discriminant, we have 2. Okay, so actually let's just go over this table. So I've given the 3 different cases of the number of x-intercepts we could have. In case number 1, this is when our discriminant is greater than 0, and there are 2 solutions to the quadratic formula. That means that we have 2 x-intercepts. Just to make you aware, you might also see this in textbooks as 2 real roots. So 2 x-intercepts and 2 real roots are interchangeable language, and you need to know both of them. In case 2, when we have our discriminant equal to 0, what's going to happen is there will be one solution to the quadratic formula. And that one solution will correspond to 1 x-intercept. So as you can see, it like just touches the x-axis. So 1 x-intercept, this language is a bit strange, but it's the same as saying we have 2 equal real roots. Okay, so this word real is important. Okay, because we need to contrast it with the last case. So the last case is when our discriminant is less than 0. So that's the thing under the square root. And if you know the square root of a negative number, we'll have no solutions there. So no solutions means we have 0 x-intercepts, okay, which means we have 0 real roots. So for those of you who know what complex numbers are, another way of saying this is 2 imaginary roots, but we're not going to talk about this in this course. All you need to know is we have 2 real roots, 2 equal real roots, or 0 real roots. Okay, there are no solutions to the quadratic formula, and what you'll know is this quadratic will never be factorable. Okay, whereas the other 2 could be factorable, although the numbers could be too ugly to actually factor. So that's all I have to say for the actual theory around the discriminant. On the next page, I'd like you to practice calculating the discriminant. I'm just going to jot down the answers, and I'd like you to check them against mine. But I do have one question that I want to do in detail with you right after that. So stay tuned and please watch the end of this video.